Hello everybody, welcome into another lesson. So today we are going to get into some very basic fundamental trig identities and quadrantal angles and reference angles. So first things to note, if you're going to find the coordinates, if you're going to find the value of the x and y coordinates at a certain angle, it's helpful to know that your cosine of the angle is your x coordinate. So the cosine will always be your x coordinate, and then likewise the sine will always be your y coordinate. So that makes life easy. Cosine is x, sine is y. And then you have, of course, the secant we know is the reciprocal of the sine function. You could just take the reciprocal of your x coordinate, 1 over x, and then cosecant's the reciprocal of the sine function, so that's 1 over y, the reciprocal of the y coordinate. And then it's also helpful to note that if you want to find the tangent, it's just y divided by x, which would be sine divided by cosine, which you can use this for all functions. Tangent is sine divided by cosine, or y divided by x. And then we know cotangent's the reciprocal of the tangent function, so that's going to be cosine divided by sine, or x divided by y. So those are very particularly useful to know. Now, we're going to start off first with what are called quadrantal angles. And you're probably wondering, what the heck are quadrantal angles? Well, let's get into those. Quadrantal angles. So quadrantal angles they lie along the axes. So 0 degrees, which is also the same as plus and minus 360 degrees, or also denoted as 2 pi for radians or 0 radians. So we have 0 degrees, which is also 360 degrees, which is also 0 radians, or 2 pi radians, right? Why don't we we're going to find the 6 trigonometric functions for this angle here. So let's take the cosine of 0. I'm going to do this in radians because I really want us to get used to radian notation, okay? So in general, at 0, your x coordinate's going to be 1, and your y coordinate will be 0. So the cosine of 0 is going to have a value of 1. So the cosine of 0 will always be 1. Now, your sine is your y. You're not going anywhere in the y direction, so your sine of 0 is going to be 0. So the cosine of 0 is 1, the sine of 0 is 0. It's also the same for 2 pi, because it's at the exact same position as 0. In fact, why don't we write that here? The cosine of 2 pi would equal 1. The sine of 2 pi would equal 0. Because cosine is your x coordinate, sine is your y. Now, what about, let's do the secant. So how about the secant at 0? The secant at 0, of course, that's 1 divided by your cosine. That'd be 1 divided by the cosine of 0, which is 1 divided by 1, so that means your secant is also 1. Now, what about the cosecant of 0? Cosecant of 0, of course, is going to be 1 divided by sine of 0, which would be 1 divided by 0, which is undefined. So the cosecant at 0 is actually undefined. It has no value. It's undefined. Now what about the tangent of 0? At 0, the tangent, well, that's the same as the sine of 0 divided by the cosine of 0. So that's going to be 0 divided by 1, which means your tangent at 0 is 0. And then we can find the cotangent of 0. The cotangent, of course, is your cosine of 0 divided by the sine of 0, which would give you 1 divided by 0, which means the cotangent at 0 is also undefined. So, if you can remember then that at 0, the cosine is 1 for your x-coordinate. The cosine's always your x-coordinate, and the sine's always your y-coordinate. It would have the coordinate 1, 0, or cosine of 0, sine 0. You can easily find your secant to be 1, your cosecant to be undefined, and then if you can remember that the tangent is sine divided by cosine, your tangent will be 0, and then the cotangents are reciprocal of the tangent, you'll find that the cotangent is undefined at 0. Now, let's go next to the 90 degrees. So 90 degrees is the same if you're, so that's going counterclockwise. If you were going clockwise, this is the exact same as negative 270 degrees. It would put you in the same position. Or in radians, 90 degrees is pi over 2. If you're going counterclockwise, the normal way, if you're going clockwise, it would be negative 3 pi over 2. Those are all the same identity for 90 degrees. So let's find the cosine of pi over 2. And again, I want to get us used to using radians. So what is the cosine of pi over 2? So this is up here along the positive y-axis. The standard coordinate at pi over 2 is 0, 1. So if you have a coordinate of 0, 1, that means that your x-coordinate is 0, so the value of the cosine of pi over 2 is 0. And then if you want to find the sine of pi over 2, well, your y-coordinate's 1, so that means the sine of pi over 2 is 1. Now we can easily find the secant of pi over 2. That, of course, is going to be equal to 1 divided by the cosine of pi over 2, which would end up giving you 1 over 0, meaning that the secant itself is undefined at pi over 2. The secant is undefined at pi over 2. Now, what about the cosecant at pi over 2? So that's going to be the same as 1 divided by the sine of pi over 2, which would be 1 over 1, which means your cosecant has a value of 1 at pi over 2. Now we can look for the tangent of pi over 2. The tangent of pi over 2, that's the exact same as the sine of pi over 2 divided by the cosine of pi over 2, which is going to give you 1 divided by 0, which means your tangent at pi over 2 is also undefined. So your secant and your tangent are undefined at pi over 2. Now what about your cotangent of pi over 2? Well, the cotangent is the same as the cosine of pi over 2 divided by your sine of pi over 2, which would end up giving you 0 divided by 1, which means your cotangent at pi over 2 is 0. So, again, your x-coordinate at pi over 2 is 0, but your y-coordinate is 1, so you have a cosine of pi over 2 being 0. Since that's your x-coordinate, your sine is your y-coordinate, which would be 1 for pi over 2. And then from those two, you can derive all the other 4 trig functions. Alright, next let's move on to pi, which would be 180 degrees. Alright, so let's look at 180 degrees, which would be in the positive direction. It's actually negative 180 in the negative direction. That's the only time they match up. You have pi for radians, and then you have negative pi also for radians. That's the only time they actually match up. So let's find the cosine of pi. So 180 goes in the negative direction, so you have a standard x-coordinate at negative 1, 0. So the cosine of pi is going to be negative 1. Since you're going in the negative x direction to get to pi, the cosine of pi is negative 1, which would mean your sine of pi, since your y-coordinate's 0, your sine of pi is going to be 0. So the cosine of pi is negative 1, which is also your x-coordinate. Your sine of pi is 0, which is your y-coordinate. Now let's find the secant of pi. The secant of pi, of course, would equal 1 divided by the cosine of pi, which would be 1 divided by negative 1, which would just give you negative 1. So the secant of pi is negative 1. Now, what about the cosecant of pi? Well, that's the same as 1 divided by the sine of pi, which would be 1 divided by 0, which would make the cosecant at pi undefined. So the cosecant at pi is undefined. Now, what about the tangent of pi? So the tangent at pi, of course, is the sine of pi all over the cosine of pi, which would give you 0 divided by negative 1, or simply 0. So your tangent at pi is 0. Now what about the cotangent of pi? Well, the cotangent this time is going to be the cosine of pi divided by the sine of pi, which would give you negative 1 divided by 0, which would make the cotangent of pi undefined. So the cotangent of pi is undefined. So the x-coordinate at pi is negative 1, which means your cosine is negative 1. Your sine of pi, which is your y-coordinate, is 0. Now let's deal with 270. Alright, so we're going to deal with 270 degrees next. That's if you're going in the positive direction. In the negative direction, this is the same as negative 90 degrees. Or in radians in the positive direction, this is 3 pi over 2. In radians in the negative direction, this is the same as negative pi over 2. So those are all the same. These are 4 different names for the same angle. But we're going to use the radian notation. We're going to find the cosine of 3 pi over 2. So again, the cosine is your x-coordinate. Since it lies along the y-axis, your x-coordinate is going to be 0. So the cosine of 3 pi over 2 is 0. Now what about the sine of 3 pi over 2? So the sine of 3 pi over 2, it lies along the y-axis here, and that's your y-coordinate. The sine of 3 pi over 2 is -1. So we got the fundamental cosine and sine. Now let's look for the secant of 3 pi over 2. Which we know the secant is nothing more than 1 divided by the cosine of 3 pi over 2. Which would be 1 divided by 0. So in other words, the secant at 3 pi over 2 is actually undefined because you can't divide by 0. So the secant at 3 pi over 2 is undefined. So then what about the cosecant of 3 pi over 2? So that's the same as 1 divided by the sine of 3 pi over 2. Which is the same as 1 divided by -1, which would give you a value of -1. So your cosecant at 3 pi over 2 is -1. Now let's look for the tangent of 3 pi over 2. That's going to be the same as the sine of 3 pi over 2 divided by the cosine of 3 pi over 2, which would give you -1 divided by 0, which means your tangent is undefined at 3 pi over 2. So the tangent's not defined there. Now what about the cotangent of 3 pi over 2? That would equal your cosine of 3 pi over 2 divided by your sine of 3 pi over 2, which would give you 0 divided by -1, or just plain old 0. So at 3 pi over 2, the cotangent is 0. So the x-coordinate at 3 pi over 2 is 0, which would be your cosine. The y-coordinate at 3 pi over 2 is -1, which would be your sine. From there, you can derive the other 4 trig functions. And I think it's kind of nice if you just can find your cosine and sine, know that your cosine's your x, your sine's your y, you can derive all the other functions, which makes life a lot easier. So the 0, the 90, the 180, the 270, all those are called quadrantal angles because they're right on the axes. Now we're going to also talk about reference angles here. So here's what we're going to do. So we're going to draw a couple of triangles that are going to help us. We're going to draw a 30, 60, 90 right triangle. We know the side opposite 30 is 1, the side opposite 60 is the square root of 3, and the hypotenuse is 2. Next to it, we're going to draw a 45, 45, 90 right triangle. So 45, 45, 90. Both sides opposite the 45 have a length of 1, the hypotenuse has a length of the square root of 2. These are going to be a real lifesaver when helping you evaluate the trig functions for what we're about to do. As I said, these come up all the time in trig. It's important to know these two triangles. So we're going to look at pi over 6, which is 30. So we're going to take 30 degrees, which is the same as pi over 6. So let's start with the cosine of pi over 6. So to find your cosine, of course, that's 30 degrees, right? So that would be your adjacent over hypotenuse, so that'd be the square root of 3 over 2. I am going somewhere with all these, don't worry, but I want to start in the first quadrant. So, square root of 3 over 2 for the cosine of pi over 6. Now the sine of pi over 6, of course, opposite 30 is 1, so that'd be 1/2. The sine is pi over 6. Let's then find the secant of pi over 6. Well, that's going to end up being 2 over the square root of 3, which would end up being 2 times the square root of 3 over 3. So the secant of pi over 6 is 2 times the square root of 3 over 3. Now what about the cosecant of pi over 6? That's the same as 1 over the sine of pi over 6, but 1 over 1/2 is 2. Now we can find the tangent of pi over 6, which is the same as sine over cosine, which would end up being the square root of 3 over 3. And then to find the cotangent of pi over 6, that's going to be cosine over sine, which would just be the square root of 3. We are doing the very fundamental first quadrant angles first. So, as you see so far, everything is positive. Everything is positive here so far. Now, why don't we deal with the 45? I'm laying a foundation here for what we're about to do here shortly. So, let's look at 45 degrees, which is the same as pi over 4. 45 degrees is the exact same as pi over 4. Let's find the cosine of pi over 4. So adjacent over hypotenuse, that would be 1 over the square root of 2, which is the same as the square root of 2 divided by 2. Now let's find the sine of pi over 4. Well, opposite over hypotenuse, that's also the square root of 2 over 2. Now, what about the secant of pi over 4? So that's going to be 1 over the cosine of pi over 4, which would be just the square root of 2. Now, what about the cosecant of pi over 4? That's 1 divided by the sine of pi over 4, which is also just the square root of 2. Now let's find the tangent of pi over 4. That's sine over cosine, which would just give you 1, because the square root of 2 divided by 2 all over the square root of 2 divided by 2 is just 1. The cotangent of pi over 4 is cosine over sine, or simply 1 divided by tangent of pi over 4, which is also 1. Again, notice all values are positive here. We're in the first quadrant. We are in the very first quadrant, okay? Let's do one more first quadrant angle. Let's do 60 degrees. We're going to do 60 degrees, which is also the same as pi over 3. So, let's find the cosine of pi over 3. So, let's see, the cosine of pi over 3, which is 60, that's going to be 1/2. So the cosine is 1/2. Now what about the sine of pi over 3, which is 60? Well, that's going to be square root of 3 over 2. From here we can find the secant of pi over 3. Alright, so the secant of pi over 3 is going to be then 1 over cosine, which would just be 2. Now how about the cosecant of pi over 3? That's just 1 divided by sine, which would end up being 2 times the square root of 3 over 3. Now let's find the tangent of pi over 3. That's sine over cosine, which would end up just being the square root of 3. Now what about the cotangent of pi over 3? The cotangent is cosine over sine, or just 1 divided by tangent. That would be the square root of 3 divided by 3. That would be your cotangent. So notice something. Here in the first quadrant, again, think of this as your normal xy plane, right? Your x and y coordinates are both positive, right? So that means the cosine in the first quadrant is positive. And by extension, because the secant's the reciprocal of the cosine function, your secant is also positive, right? If your y is positive, that means your sine is also positive in the first quadrant. And by extension, since the cosecant's the reciprocal of the sine, your cosecant is also positive. Now, what do we know about tangent? Well, tangent is sine over cosine, right? Well, positive divided by positive is positive. So your tangent is positive in the first quadrant. Now, by extension, then, your cotangent's also positive because 1 divided by a positive is a positive. So everything in the first quadrant is positive. Now, here's where we get interesting, because up until now we've largely been working with first quadrant angles. That changes today. We're about to get into second, third, and fourth quadrant angles. So let's say we were asked to find 2 pi over 3, which is 120 degrees. 120 degrees, which is 2 pi over 3. That's definitely in the second quadrant, right? Here's 2 pi over 3, which is 120 degrees. That's in the second quadrant, isn't it? Well, there is something here, though, for that. There's something called a reference angle. Whenever you're dealing with anything in the second, third, or fourth quadrant, you have to consider what is called a reference angle. How do you find a reference angle? You're going to take, it always varies off the x-axis. So in the second quadrant, you're going to take pi and subtract the angle you have. So in this case, you're going to take pi minus 2 pi over 3, which would just give you pi over 3, right? So your reference angle would be pi over 3. This would be treated, in other words, like a 60-degree angle, only in the second quadrant. In fact, let me label the quadrants here. This is quadrant 1. Here's quadrant 2 up here to the left. Here's quadrant 2. So 2 pi over 3 you're actually going to treat like a 60-degree angle, only it's going to be in the second quadrant. A big common mistake people make is they think, well, 120s, that's only 30 degrees past 90. And then they tend to treat it like a 30-degree angle and they get the wrong answer. Indeed, it is wrong. You have to go by the x-axis and not the y, because you'll get the wrong answer every time if you do that. So let's find the cosine of 2 pi over 3. Okay? Now keep in mind we're treating this like a 60-degree angle, right? Because it's pi over 3. But we're in the second quadrant. If we remember from basic xy coordinates, what is true about the second quadrant? Your x coordinate is negative, right? It's always negative. So let's look at 2 pi over 3, which would be 60. The cosine is adjacent over hypotenuse. Normally for pi over 3 it'd be 1/2, but since you're in the second quadrant, you're going to put a negative sign. So your cosine at 2 pi over 3 is actually negative 1/2. So this is where people think we have a negative length. Well, yes and no. There's really no such thing as a negative length. That negative just indicates which direction you're going. So that's all a negative length indicates. So it just indicates which direction you're going. So for cosine, that would indicate you're going to the left on the x-axis. Now let's find the sine of 2 pi over 3. The sine of 2 pi over 3, well, again, we're in the second quadrant. Your y is still positive, right? So you have a negative x but a positive y. Well, the sine is your y coordinate, so that means the sine of 60, which is 2 pi over 3, that'd be the square root of 3 over 2. But it's going to be positive square root of 3 over 2. So your cosine's negative, but your sine is positive, because your x is negative and your y is positive. So then let's go ahead and find the secant of 2 pi over 3, which is going to then be 1 over your cosine of 2 pi over 3. That would just be negative 2. So your secant is negative because your cosine's negative. Now what about the cosecant of 2 pi over 3? Well, keep in mind, that's the reciprocal of your sine, right? So since your sine's positive, your cosecant will also be positive. So that's going to be 2 times the square root of 3 over 3. Which then by extension we can find the tangent of 2 pi over 3. Now, what's true about tangent? That's your sine divided by cosine, right? Well, if you have a positive divided by a negative, what do you get? You get a negative every time, right? If you divide a positive by a negative, you're going to get a negative. So in this case, it's actually going to be negative of the square root of 3 is what you'll get for the tangent. Now what about the cotangent of 2 pi over 3? Alright, so the cotangent, well, this time that's the cosine over sine, so that's a negative divided by a positive. A negative divided by a positive will be a negative every time. So this will end up being negative of the square root of 3 over 3. So notice, since your cosine is negative but your sine is positive, your tangent and cotangent will be negative. Your secant will be negative, but your cosecant will be positive. Now, why don't we deal with 3 pi over 4? We'll deal with 3 pi over 4, which is 135 degrees. So let's find 135 degrees, which would be 3 pi over 4. Well, let's find the reference angle here for that. What's the reference angle for the 135 or the 3 pi over 4? So take pi minus 3 pi over 4, and that would just give you pi over 4, right? You're going to treat this like it's pi over 4 or a 45 degree angle. So here's 3 pi over 4 right here in the second quadrant again. Now, let's look for the cosine of 3 pi over 4. Alright, so the cosine of 3 pi over 4, so you're in the second quadrant, that means your x-coordinate is negative. So that means your cosine is going to be negative. So at 3 pi over 4, you'll have 1 divided by the square root of 2, which is square root of 2 over 2. It's actually going to be negative of the square root of 2 over 2, since your x-coordinate is negative. Now, then we can find the sine of 3 pi over 4, which is, at this point, you still have a positive y-coordinate in the second quadrant, so that would just be positive square root of 2 over 2. So you have a negative cosine, positive sine. All right, now what about your secant of 3 pi over 4? Well, 1 divided by a negative is a negative, right? Because secant's the reciprocal of your cosine. So that's just going to be negative of the square root of 2. Now what about your cosecant of 3 pi over 4? Well, the cosecant's the reciprocal of the sine. If the sine is positive, you'll get a positive value for your cosecant. So that's going to end up being positive square root of 2. Now let's find the tangent of 3 pi over 4. So the tangent, that's sine over cosine, right? So positive square root of 2 over 2 all over negative square root of 2 all over 2. That's going to give you negative 1, right? So your tangent would actually be negative 1 for 3 pi over 4, which also means your cotangent's going to be negative. So the cotangent then is just 1 over your tangent, which would also be negative 1. So you're probably starting to notice a common theme in the second quadrant. Your cosine's negative because your x-coordinate's negative, and your sine is positive, which makes because your y's positive, which gives you the value of all the other trig functions. Now let's do 150 degrees, which would end up being 5 pi over 6. Alright, so let's do 150 degrees, which is the same as 5 pi over 6. So let's find the reference angle first, so we know how to treat this. So you'll take your pi minus 5 pi over 6, which would give you a reference angle of pi over 6, which would be treated like a 30-degree angle. So here's 5 pi over 6, still very much in the second quadrant. Your reference angle you're going to treat like pi over 6, which would be like a 30-degree angle. So let's find the cosine of 5 pi over 6. Alright, so cosine of 30 is going to be square root of 3 over 2, but since you're in the second quadrant, your x is negative, it's actually going to be negative of the square root of 3 over 2 for the cosine of 5 pi over 6. Now what about the sine of 5 pi over 6? Well, in the second quadrant, your y is still positive, which means your sine is positive. So you're going to get positive 1/2 for your sine of 5 pi over 6. Now, let's find the secant of 5 pi over 6. Well, since your we know the secant is the reciprocal of the cosine, and your cosine's negative, your secant's going to be negative 2. So that would be negative 2 times the square root of 3 over 3 for your secant. Now let's find the cosecant of 5 pi over 6. Well, cosecant's the reciprocal of sine. If your sine's positive, your cosecant will also be positive. So 1 over 1/2 is 2. So your cosecant is positive 2. Now, what about the tangent of 5 pi over 6? Well, that's sine over cosine. A positive divided by a negative gives you a negative, right? So that's going to end up being negative of the square root of 3 over 3. And then we can find the cotangent of 5 pi over 6. Well, that's cosine over sine, so negative divided by positive is going to give you a negative. So that would give you negative of the square root of 3 for the cotangent of 5 pi over 6. So we've now covered the second quadrant completely. Since your x-coordinate's negative, that means your cosine will be negative, which also means your secant has to be negative, right? Because that's the reciprocal of cosine. But your y-coordinate's positive, which means your sine is still positive, which means your cosecant has to be positive, since that's the reciprocal of sine. Which means then, since tangent is sine divided by cosine, your tangent would have to be negative. And since cotangent's 1 divided by tangent, your cotangent is also negative. So your sine and cosecant are positive in the second quadrant. Everything else is negative. And you guessed it, we're about to go into quadrant 3. Let's go into quadrant 3. Let's talk about all that. So we're going to keep those reference triangles up there, but it changes a little bit again as we get into the third quadrant. Let's do 7 pi over 6, which would be 210 degrees. So let's do 210 degrees, which would be 7 pi over 6 in terms of radians. To find the reference angle in the third quadrant, because the third quadrant's past pi, it's below the y-axis, right? So you got to take the angle, subtract 180 from it. So you would take 7 pi over 6 and subtract pi, which should give you pi over 6. So 7 pi over 6 gets treated like a pi over 6 angle, which would be treated like a 30-degree angle. Now let's find the cosine of 7 pi over 6. So keep in mind we're in the third quadrant, which your x-coordinate's still negative in the third quadrant, so that means you're going to get a negative value for the cosine. So the cosine of 7 pi over 6, will that be negative of the square root of 3 over 2. Alright, now, what about the sine of 7 pi over 6? Okay, so notice too, we're in the third quadrant now, your y is also negative. So 7 pi over 6, that gets treated like 30, that's going to be negative 1/2. So this time your sine is also negative. Now, let's go ahead and find the secant of 7 pi over 6. So 7 pi over 6, well, keep in mind, secant's the reciprocal of cosine, right? If your cosine's negative, so will your secant be. So that would be negative 2 times the square root of 3 all over 3. Now what about your cosecant of 7 pi over 6. Alright, well, also keep in mind the cosecant is the reciprocal of the sine function, right? If your sine's negative, so will your cosecant be. So 1 divided by negative 1/2 is negative 2. So the cosecant will be negative 2. Now here's where it gets interesting. Tangent and cotangent are about to get very interesting. What is tangent? That's sine divided by cosine, right? Well, notice something. In the third quadrant, sine and cosine are both negative because tangent sine over cosine, and negative divided by negative is actually positive. So in the third quadrant, your tangent would actually become positive again. So that's going to end up giving you positive of the square root of 3 over 3 for the tangent. Now what about the cotangent? Okay, well, cotangent is what? That's going to be cosine over sine. Since those are both negative, a negative divided by a negative is a positive. So that would actually give you positive square root of 3 for the cotangent of 7 pi over 6. So far you're seeing everything is negative in the third quadrant with the exception of the tangent and cotangent, and those end up positive. Now let's continue here in the third quadrant, and you guessed it, we'll do the fourth quadrant after that, then we'll be done with the lesson. Let's do 5 pi over 4, which would be the same as 225 degrees. So let's find 225 degrees, which is the same as 5 pi over 4. So to find the reference angle here, again, we're in the third quadrant, right? We're in the third quadrant, so you're going to then take, of course, 5 pi over 4 minus pi, which would mean pi over 4 is your reference angle, which would be treated like a 45-degree angle. So let's find the cosine of 5 pi over 4. So the cosine of 5 pi over 4, well, you're going to treat it like the cosine of pi over 4, which would be square root of 2 over 2. However, in the third quadrant, your cosine's negative. So this would be negative of the square root of 2 over 2. Now what about the sine of 5 pi over 4? Alright, so again, it's going to be opposite over hypotenuse, so that'd be square root of 2 over 2, but your y-coordinate is also negative in the third quadrant, which means your sine is also negative. So that'd be negative square root of 2 over 2. Now let's find the secant of 5 pi over 4. Well, that's 1 divided by cosine. 1 divided by a negative is a negative, right? So that would be negative of the square root of 2. Now let's find the cosecant of 5 pi over 4. Well, cosecant is 1 divided by sine, right? 1 divided by a negative is a negative. That's also going to be negative of the square root of 2. That'd be negative of the square root of 2 for your cosecant of 5 pi over 4. Now let's find the tangent of 5 pi over 4. Which, again, it's interesting in the third quadrant because tangent is sine over cosine. Well, negative divided by negative is positive. So you're actually going to get positive 1 for your tangent of 5 pi over 4. And then cotangent's just 1 divided by tangent, right? Which means your cotangent is also going to be positive 1. And I got one more angle in the third quadrant, then we'll move on to the fourth. Alright, so let's do 4 pi over 3, which would be the same as a 240 degree angle. So let's deal with 240 degrees, which is the same as 4 pi over 3. So let's find the reference angle first. So you're in the third quadrant, so you'll take 4 pi over 3 minus pi. That would treat it as pi over 3, or in other words, a 60 degree angle. You're going to treat that like you would a 60 degree angle, or pi over 3. So let's find the cosine of 4 pi over 3. Alright, so the cosine of 4 pi over 3, which is like 60, that would end up being 1/2, but since you're in the third quadrant, your x is negative, your cosine would actually be negative 1/2. Now what about your sine of 4 pi over 3? So that, of course, the sine of 60 would be square root of 3 over 2, but your sine's also negative in the third quadrant, so you'd actually get negative of the square root of 3 over 2 for your sine. Alright, now what about your secant of 4 pi over 3? Well, if your cosine's negative, so is your secant. So you would end up getting negative 2 for your secant. Now what about your cosecant of 4 pi over 3? Okay, so the cosecant, reciprocal of sine, since your sine's negative, your cosecant's also going to be negative 2. So that would be negative 2 times the square root of 3 all over 3. Now what about the tangent of 4 pi over 3? Well, it's sine over cosine, so negative divided by negative is positive. So that's actually going to be positive square root of 3 for the tangent of 4 pi over 3. So what about the cotangent of 4 pi over 3? Well, that's just 1 divided by tangent. If your tangent's positive, so is your cotangent. That would give you the square root of 3 all over 3. Alright, so now we have seen the third quadrant. So what's true for the third quadrant? Your x, which is your cosine, is negative, which means your secant's going to be negative since that's the reciprocal. This time your sine's also negative, which means your cosecant will also be negative. However, your tangent is positive because it's sine divided by cosine, so you have a positive tangent, and then by extension a positive cotangent. So these are all useful pieces to know about each quadrant. Now, you guessed it, for the final part of this lesson we're going to do quadrant 4. Let's do quadrant 4. So let's go ahead here. And why don't we do the 300 degrees, which would be 5 pi over 3. So we're going to do 300 degrees, which is the same as 5 pi over 3. So we're now in the fourth quadrant. Let's find the reference angle. Now keep in mind, as I've stated, we are in the fourth quadrant. Your reference angle is going to be 2 pi or 300, it's going to be taking away from 2 pi or 360. So in the fourth quadrant, you would take 2 pi and subtract whatever your current angle is, which is 5 pi over 3, which means your reference angle would be pi over 3. So you're going to treat this like another 60-degree angle. So let's go ahead and find the cosine of 5 pi over 3. So the cosine is of pi over 3, which is 60. That'd be 1/2. And your x-coordinate in the fourth quadrant is actually positive, right? So you have a positive 1/2 for the cosine of 5 pi over 3. Now let's find the sine of 5 pi over 3, which is the same as 60. So the cosine, that'd be square root of 3 over 2. However, your y-coordinate in the fourth quadrant is still negative, so your sine of 5 pi over 3 would be negative square root of 3 over 2. Now let's find the secant of 5 pi over 3. So that's going to then, since your cosine's positive, that means your secant will be positive. So 1 over cosine, in this case, that'd be 1 over 1/2. That would give you positive 2. So your secant's positive 2, but what about your cosecant of 5 pi over 3? Alright, so cosecant is the reciprocal of sine. And since the sine is negative in the fourth quadrant, so that's going to actually be negative 2 times the square root of 3 over 3. Now let's deal with the tangent and cotangent. So the tangent of 5 pi over 3, well, that's sine over cosine, and negative divided by positive gives you a negative. So your tangent will be negative again. So that's going to end up being a negative of the square root of 3. And then let's find the cotangent of 5 pi over 3, which is simply 1 over tangent. 1 divided by a negative is a negative. So you get negative of the square root of 3 over 3. So you notice this time your cosine's positive, your sine's negative, which makes your tangent and cotangent negative again. So if you notice, it's interesting, your tangent and cotangent are only positive in the first and third quadrants. In the second and fourth, they're negative. And so it's kind of neat how the tangent and cotangent work diagonally like that in the first and third quadrant. But I have 2 more angles we're going to do, and then we'll be done with the lesson. Let's do 315 degrees, which is 7 pi over 4. So 315 degrees, which would be 7 pi over 4. So we're going to find the reference angle first. Alright, so the reference angle in the fourth quadrant, you'll take 2 pi and subtract that 7 pi over 4, which would end up giving you pi over 4 as your reference angle. So this is going to be treated like pi over 4 or a 45-degree angle. So let's now go ahead and find the cosine of 7 pi over 4. Okay, so the cosine of 7 pi over 4, so cosine's positive since you're in the fourth quadrant. That's going to be 1 over the square root of 2, which would just be the square root of 2 over 2. So this time, what about the sine of 7 pi over 4? Well, in the fourth quadrant, the sine is negative, so this would be negative of the square root of 2 over 2. Now what about the secant of 7 pi over 4? Well, 1 divided by cosine, 1 divided by positive gives you a positive, so that's going to give you positive square root of 2. Now what about the cosecant of 7 pi over 4? Well, 1 divided by sine, so 1 divided by a negative is a negative. You'll end up actually getting negative of the square root of 2 for cosecant of 7 pi over 4. Now let's do the tangent of 7 pi over 4. So sine divided by cosine, so negative divided by positive gives you a negative. You'll end up getting negative 1 for your tangent. Now what about your cotangent of 7 pi over 4? Alright, well, 1 divided by tangent, 1 divided by a negative is a negative. So your cotangent is also negative 1. And one more angle, then we're done with the lesson. I know this has been a rather long, drawn-out lesson, but these are very, very important for the future. What we're going to be doing even in this course, let alone in pre-calc and in calculus, these are all very important fundamental angles we need to have. This time, let's do 330 degrees, which is 11 pi over 6. So we'll deal with 330 degrees, which is the same as 11 pi over 6. So let's find the reference angle for that. Reference angle, you'll take 2 pi minus 11 pi over 6, which means your reference angle is pi over 6, or 30 degrees. So you'll treat this like pi over 6 or a 30-degree angle. So let's find the cosine of 11 pi over 6. So cosine's positive in the fourth quadrant, so that would end up being square root of 3 over 2. Now what about the sine of 11 pi over 6? Well, the sine is negative in the fourth quadrant, so that would end up being negative 1/2 for the sine of 11 pi over 6. So now let's do the secant of 11 pi over 6. Well, since your cosine's positive, your secant will also be positive, so that would be 2 times the square root of 3 all over 3. Now what about your cosecant of 11 pi over 6? Well, your sine is negative, so your cosecant will also be negative. So 1 divided by negative 1/2 will give you negative 2. So the cosecant will be negative 2. Now let's deal with the tangent of 11 pi over 6. The tangent, of course, sine divided by cosine, negative divided by positive is negative. So you would end up getting negative of the square root of 3 over 3. And then the cotangent of 11 pi over 6. Well, 1 divided by tangent, 1 divided by a negative is a negative. So that would be negative of the square root of 3. So those are all your values for the special angles in the fourth quadrant. So now, what is going to be true here for the fourth quadrant? Alright, so in this case, the cosine's positive, right? Because your x is positive, which means your secant will also be positive. But your sine's negative because your y is negative, so the sine is negative, which means your cosecant will also be negative. And then tangent sine over cosine, so that means your tangent's going to be negative, and then by extension your cotangent would also be negative. So I don't know if you want to copy these down or not, but these are the special relationships with the 6 trig angles in the 6 trig functions in each quadrant. And as you see, every angle we've done today is based off the 30, 60, 90 and 45, 45, 90 right triangles. So it is so important that you remember these triangles. And I would suggest when you go to solve these problems that you draw a diagram of these triangles for your reference. I still do it, and I've been teaching math. I do calculus and all that stuff. It helps me even then to set up my triangles so I have them to reference. And then knowing how to find reference angles, knowing how to convert between radians and degrees are very helpful. So next lesson we're going to talk about finding trig functions of any angle. So I hope everyone has a great day. Take care.